Okay, welcome everybody to the October 2022 virtual meetup for SF Bay Area ClickHouse. We have a great session today. We will have Yusuf Osturk talking about virtual metrics, and we also have Lorenzo Mangani, who's going to talk about Quarian, which is a serverless implementation of ClickHouse, which is very cleverly built. And then after the meetup, as usual, we'll do kind of a Q&A discussion / melee about ClickHouse for as long as you want. We could run for 2 hours. Any questions are free, are welcome. My name is Robert Hodges, and I'm the CEO of Altinity. So we've been running this meetup for many years now. I think it first started back in 2017. It's been around for quite some time, and we've had the pleasure to. We try to meet every 2 months. Last month I kind of missed because we were doing a bunch of other stuff, and it was hard to get set up. But we'll definitely meet in December. There's lots of interesting stuff going on. Before we dive in, I'd just like to pitch really quickly. We have a conference coming up. It's called OSACon. It's Open Source Analytics Conference. It's everything about open source and analytics software. The agenda is going to be really interesting. We've got all people all the way from David Nally and Max Beauchemin and others talking about the foundations of, well, sort of the future of open source and analytics. David Nally is head of open source at Amazon, and Max, I think everybody knows from, probably knows from as the author of both Airflow as well as Superset. We have many others. Peter Zaitsev. We have about 30 talks, and we have a bunch of people, sort of in the community who are helping to promote it. It's on November 15th. It's virtual. It's completely free. We invite everybody to sign up. Please tell your friends. It's going to be a really good conference. And just some of the people: Max Beauchemin, Peter Zaitsev, of course me, because we're running it. Doug Cutting is another person. He was the one who first designed Hadoop. So, and they're just a few of the people talking about this. We'll be looking at things like HTAP, Apache Arrow, as well as a lot of ClickHouse talks. We have ClickHouse talks from Alexei Milovidov and a number of other people who are doing various types of ClickHouse implementations. So it should be really interesting. So I'd like to welcome you. With that, and one more thing I'd like to mention is we will meet in 2 months. If you have something on ClickHouse that you'd like to talk about, please do contact us. You can send me a message. We can also, you can send information to info@altinity.com. Just contact us and say you'd like to present. I'll be most likely to, in fact, we as a team will be most likely to see it if you post it there. But it's pretty much anything. If you have anything open source in ClickHouse, we'd like to hear about it. Good. With that, I'm going to cue it up for our first speaker. So Yusuf Osturk, I had the pleasure of meeting him Yusuf, I think it was about 6 weeks ago, something like that we first got together. Mm-hmm. And Yusuf is going to be talking about how ClickHouse enabled virtual metrics to evolve its analytics. And I'm not going to say any more, but Yusuf, I'll turn it over to you and just go ahead and share your screen, and the stage is yours.
Thank you, Robert. Thank you for the opportunity as well. Let me go with my screen. Is it all good?
I see it. Yes.
Okay.
And your
perfect.
audio is great. So go for it.
Okay. Great. Thanks. So yeah, this is about the virtual metric version 8, and I call it as evolution of a product. So I would like to start with the founders team and myself. So my name is Yusuf Osturk. I'm the co-founder of Virtual Metric BV. I have more than 10 years of experience in IT and software engineering. I'm originally a mechanical engineer. but I love doing this job. I love working on the computer stuff. So yeah, now I'm doing this. And in the past, I've worked with many companies like banks, telco companies, and I was a Microsoft MVP for 5 years. And now, yeah, I'm in the Virtumetric. And my other co-founder is Ali. He's also investor and accelerator of the Virtumetric. And yeah, he's also doing some other investments in the market. So I would like to start with Virtumetric. Then I will tell you like how we evolved the product over the years. So today Virtumetric is actually IT infrastructure management and monitoring solution. So what we do is like we go to customers and we install our product inside of their environment, and then we get many stuff from their servers or devices, and out of that information we give them like bunch of reports. This can be, for example, a budgeting for their next year's investments or any performance related issues. So basically it's a monitoring solution. We founded the company in 2016 in Amsterdam. We have now around 13 people, and they're located in Netherlands, Bulgaria, and Turkey. And in addition to like monitoring solutions, we are aiming to add cybersecurity features in the upcoming years. So I would like to start with the beginning, how we started, because this presentation will be all about our experience, like what we did, how we evolved, and what are we doing today. So Virtumetric actually started with Hyper-V monitoring. I don't know if you know Hyper-V, but it's a virtualization solution. And there are other virtualizations like VMware or like the OVIRT, etc. So we started with Hyper-V monitoring. It was very simple idea. And Virtumetric actually comes from the virtualization metrics because we were designed to monitor virtualization. And our first solution was on .NET API plus a basic HTML dashboard and Microsoft SQL. Yeah. So we had to start with Microsoft SQL because around that time, we are talking about 2015s, most of the enterprise customer was asking for the SQL support. Maybe, I mean, of course, there are many reasons, but one of them was like, yeah, they already have the SQL teams, developers, they have their support, they are very good relation, they have very good relationship with Microsoft. So yeah, their preferred option is Microsoft SQL. And another thing that we were doing at the time was our solution was completely agentless via WinRM. So when the customer had a Hyper-V server, we were connecting to that remotely and getting the metrics through the WinRM. But this was very expensive solution because it was using like 250 megabytes to 1 gigabyte memory per Hyper-V host. But if you think that Hyper-V host usually has 32 gigabytes RAM to up to 2 terabytes RAM, because it's a virtualization host, it was basically nothing. It was still working and it was agentless, so it means that there was no hassle for the teams. And we were able to get real-time metrics in 1 second via WinRM. It was miraculous, but it was working. And we had Hyper-V inventory, Hyper-V guest monitoring, and Hyper-V change tracking. So we had a bunch of support and features at the time for the Hyper-V. And let's talk about the Microsoft SQL design, because it is our core, right? We are going to store everything in the Microsoft SQL. So we have to do this in the SQL, but how are we going to do that? What will happen to our tables? I mean, we are going to get a bunch of details about the hosts. So how are we going to store them? How are we going to aggregate them, like weekly, monthly, etc.? And how can we give a good performance for short range data? I would like to give a note here. I mean, of course, we switched to ClickHouse, but SQL at the time was pretty fast as well. If you know how to configure it well, it works pretty good. So we weren't unhappy with Microsoft SQL for a while, but of course, at some point, you see that it's not enough. But I will tell you why. So we were thinking like bunch of different scenarios, like how we're going to store the metrics, because we are collecting bunch of metrics. Like if you go to a product, even today, if you go to a solution on the market, they usually get you 10 metrics or 100 metrics from each device. But for a real system engineer, it's not enough. You have a bunch of metrics. You need to get latencies, IOs, like each details from each device or like each disks. And it means maybe thousands of metrics per second from the machines. So how are we going to do that? Do we have to do a different table? So we were thinking about like how we can store that, how we can read that on SQL. And this is like around like 2004, 2005. Sorry, 2014 and 2015. So I was checking the markets, and at the time I met with InfluxDB. It was pretty new. I think Influx was on the market since 2000 something, like 13, 14. So it was pretty new. And I was checking like how they do that, because if they do that somehow, and maybe we can implement this into the Microsoft SQL as well. So I checked their logic. I checked how they do the data partition, and we had to support some feature requests. Like, for example, customer comes to you and says like, yeah, you are collecting all the metrics, let's say 10,000 metric per second, but why would I keep network drop packets, for example, a metric after a month? I don't need it. I just need some metrics for a short period of time, maybe 1 week. After that, I don't need it anymore. So we had to design a solution to cover all these scenarios. And eventually, we found a solution. It's based on InfluxDB like a design. So we did different tables on the SQL for each metric group. So let's say we have VMs. We had different tables for the VM memory, VM disk, VM network. So imagine how many tables we have in the SQL. And then we had to separate them by the hourly, daily, weekly, and monthly partitions. So to do that, we separated them. And then even we added a cache table, because we didn't want to calculate the data each time. I mean, today we do this very easily with the ClickHouse, but imagine that before ClickHouse, how we were designed to do this. And then after we did this, it was pretty similar to InfluxDB, but we were giving really, really good performance on the SQL Server. And most of our customers were like surprised, and they were even saying like, is this real? Is this a fake data? Or, I mean, how are you doing this? But it was just the design and like partitioning. So it's worked very well for us. In the screenshot, you might see like epoch levels. Like we were storing every data in the epochs, like the Linux time series, format. And each table had a different level of the epoch. So when we are migrating the data from the table to table, we were eliminating some of the metrics or aggregating them based on these times. We were just grouping and aggregating the data. It was pretty simple. And it worked very well. And then we were thinking about how about the Windows event logs? So we know that some critical events are actually in the event logs, right? I mean, in the Windows especially. So if you want to get, for example, clustering events or virtual machine blue screen of that events like BSOD or live migration events, they're all in the event logs. So we have to collect them so our customers can convert them into the alarms. So it means that logs are going to Microsoft SQL. We were talking with the team at the time, and we were thinking like, yeah, should we use Elastic for this, or what shall we do? We didn't want to make our environment complex, because we were always thinking to provide a really, really easy solution, even at that time. So we didn't want to do that, and we decided to stay on Microsoft SQL at the time. But there was one problem. We weren't able to apply the same metric logic here, because in the logs, you cannot aggregate in log data because you need them. So we weren't able to do that, but at least we did separated log tables for each event type, for example, system log, application log, etc. But then it became with more problems. These are the real life scenarios. I mean, we passed through many bad times. You may never know how we are happy with ClickHouse at this stage. So what did we have with the SQL? As I said, it's really good product, but we had some terrible issues with the SQL. First one was like the Microsoft SQL locks, and another one is like the index sizes, and of course low compression ratios. It was terrible, really nightmare. And then data aggregation performance was really bad. Imagine that you are moving bunch of metrics, like millions of metrics from each tables, so you can give a really good performance, but it's really, really bad. Later on, we implemented SQL partitions, so we made this process really well, really better. I just forgot to mention one thing. This solution is completely on-prem. This is not a cloud solution. We are going to enterprises and we are giving the virtual metric to them, and they're installing in their environment with enterprise support. So please, when you're listening me, imagine that everything will be remote. So you don't have access to the systems, only customers calling you when something is down, and it's complete up to them. So you need to give as easy as possible to them, a solution as easy as possible. So it wouldn't make many issues for you, because every issue means a support case for you. And yeah, we don't want to do that as a startup. So another one, a retention job. We have to do a retention, right? I mean, we have to clean some logs because otherwise it's keep growing. And making a retention job on SQL Server, it's a nightmare. We had many bad experience with it. Even sometimes if your retention job is stopped, I think after like 100 minutes, maybe 1 billion record on SQL Server, you have nothing to do. You just need to wait. You need to have really, really fast disks. You have no other option to do. We had 3 times really a nightmare, and we had to truncate entire table because your customer said like, yeah, we can't do anything. So we also said like, yeah, there's nothing to do. So they truncated a lot of data. So it was really bad, and we were like keep thinking like, yeah, how we can do this better at the time. And another issue was, of course, the high CPU memory in SQL Server, and especially temp DB usage. It's also a nightmare. Like, keep growing. Customer configures the database as like for the backup, like full logs, and then their backup service is not running for the night, and even one night it grows really badly. So yeah, it's a bunch of issues. And another one is, of course, high IO, like using these disks really, really badly. And I can easily say like data is unmanageable after 100 gigabytes. You have nothing to do. And one customer case, we had 6 terabytes of log data, 6 terabytes for 3 to 4 months. Imagine you are querying for something in SQL database at one table, it's 3 to 4 months worth, and 6 terabytes, it takes hours. Basically, the customer was waiting like hours and hours to bring the results. But they were fine with it because at the time we didn't have any better technology. I guess that was the problem. So what we were doing at the same time, I mean, we were pretty okay actually with SQL if we don't count these big issues. I mean, it was still going well. But at the same time, we had to do some improvements at the product level. We were keep growing, and we added Windows monitoring as an addition to Hyper-V monitoring, because before we were only focused on the hypervisors, and then we added Windows monitoring. And then, because we were using PowerShell mostly, we were monitoring VMware as well. And then we were thinking like, how about Linux? Like how we can collect that? And then we met with Golang. And then we added other devices like the network devices through the Golang, and then the other bunch of things. Robert, I never ask you to about like the how many minutes I have to talk.
Oh,
Sorry.
yeah, go for like 35.
Okay, perfect. So yeah, I will be pretty fast because I have many slides. So how about the performance? After we switched to Golang, we changed many things. And on VMware, we saw that from 10 gigabyte memory usage became 50 megabytes of memory. It was insane, right? I mean, from 10 gigabytes for one vCenter and then 50 megabytes for the same vCenter, it was crazy. And then for Windows, we like basically made the memory usage from 200 megabytes to 20 megabytes. So it was a bunch of good stuff for us. And we loved Golang at the time. So we were very good at the device monitoring. Then when our life was still really happy, a customer came to us and asked this question. Can you support 2 terabytes of logs per day with disaster recovery support and without third-party licensing costs? So we were like, yeah, how are we going to do it? I mean, we are pretty good with the log monitoring and it's all auto discovery. The customer doesn't need to do anything. And yeah, we are able to get it, but how are we going to store that data? I mean, it says 2 terabytes per day, right? So how are we going to do that on SQL Server? And we already have one customer with 6 terabytes of data for 3 to 4 months. Yeah, it was I don't know, unmanageable. And then we met with ClickHouse. So the first time when we saw the ClickHouse, we were checking the performance and the benchmarks. And then we were looking for an enterprise support. And that was the time that we start with the Altinity. It was a really good talk and they helped us a lot. Even we got development support from Altinity. It was perfect. We were asking all the questions we have because we had pretty bad experience with the SQL Server. So thanks to Altinity, they were replying with very fast about the answers. So we designed the database entirely based on our experiences and with their support. And then we put it in action. We migrated the customer with 6 terabytes of SQL data. You might say, like, how can you migrate the data of like 6 terabytes to ClickHouse? Because yeah, it's really big and it's unmanageable. It's a really big table. We got help from Altinity, like how we can do the best. I mean, exporting is one issue, but importing the data to ClickHouse is also another issue. So we got help and we did our custom migration script at that time. So basically we were using like bulk exports from SQL Server and we export the data in 1 day and a half or something. I mean, I don't think you can do any better because we were using really, really good technique there. So, and then we imported the data in 1 day to the ClickHouse. And then we saw that 6 terabytes of data became 150 gigabytes. We were like, wow, what's happening? The customer was keep asking like, is this the same data? Did you really migrate all the data to the ClickHouse? Are you sure? They were checking like how many rows they have in SQL Server. So they were comparing with the ClickHouse and it was the same number of rows. They were like, no way. And then the same queries takes more than hours. We saw that the same query took less than 100 milliseconds. They were like, yeah, the mind blown, right? So the customer jokes and said like, yeah, why do I have to store 3 to 4 months of data? I can now go up to 10 years. So they were very, very happy. So let's go back to the previous problem. How to handle 2 terabytes of logs per day. So we were still thinking like, yeah, how can we do that in the ClickHouse? I mean, choosing ClickHouse is not enough, right? You have to think of everything, like how you are going to store the data if the ClickHouse is down, how you can support active ClickHouse installation. I mean, Altinity offers you many different scenarios for the, like, I don't remember the names, but like master or like super clusters, etc. But it's very complex. Imagine that, or think that this is an on-prem solution we cannot do this in the own cloud and give the solutions to the customers, but we have to install this in each customer. So this solution should be very, very simple. And of course, never trust customer network. Customer can tell you like, yeah, in each region, I have less than 50 milliseconds latency in the network, but don't trust them. And another thing is that split brain scenarios. What happens if one of the DC is completely down? What will happen? How are you going to handle that? And what will be your data format? How are you going to transfer the data? What will be your compression between the stuff, etc.? So it was lots of questions and a joke, and I got my first white hair at this time because yeah, it was pretty a lot of issues. And of course, terrible log monitoring experience. I mean, with other products, many products, you see that they're based on third-party agents, right? I mean, if you choose a product and say like, yeah, I would like to get your solution, then they say like, yeah, install this agent, like a third-party thing, and then send me your data. Or you see that they only support predefined logs. They say like, yeah, I can only get Apache logs or like this. The rest, no, there's no solution. Or like Elastic, you have to do custom configs. You have to open the notepad, put your data, like what you're going to collect, etc. So it's too much work. We weren't able to handle 2 terabytes of log if we go something like this. So we developed something called Virtuometric Reader. This is a true, not okay, let's not say true AI, but a full automated AI-based log collector. So basically, we developed this to automatically detect the file, parse it, and turn them into the ClickHouse format. So we are using a format to send the ClickHouse, and basically we were handling all the logs automatically through the Virtuometric Reader and putting them into the ClickHouse format. So we handled lots of logs with it. And then customer setup. How did we do that? This is like a pretty basic explanation. So the customer installed a local collectors onto each site. There's like Istanbul and Ankara sites, 2 different regions, let's say. So these local collectors became cluster. And then we were getting the data from each device and putting like the custom collectors inside of the machines. And these ones were sending the data back to the local collectors. And then they were going to a queue system. And then during the queue, we were replicating the data between the ClickHouses. So it was fully controlled, full automated, and ClickHouses weren't doing any clustering between the regions. We were handling everything, and it was working very well. So yeah, it was a quite success for us. And then compression rates. After the migration, we saw that customer actually validated this, that they had like different compression levels. I don't want to mention everything because I don't have much time, but you see from the screen, we did 98% compression from the most of the log data, including net flow, event log, and syslog. It's insane. I mean, it goes up to 99% even. So thanks to ClickHouse and Altinity, because they really help us how we should compress the data, because there are different column-based compression formats. So yeah, we use them and we listen them. So performance rates. We did an active high throughput monitoring, right? So we had to support really a lot of files per second. So our solution is supporting more than 1 million messages per second. It's insane. And we are doing this very moderate machines. We don't have like really high-end devices. Collector performance. We are collecting all these data and we are only using between 1 to 3% CPU from each device. It's basically nothing. Customer was very happy, and we had to improve many things, including a built-in homemade load balancer. One of the issues we saw, because we're installing this to the customer side, one day we were having package drops. And we're like, yeah, what's the issue? What's the issue? Like, what's happening? We don't know. And then we realized that the customer is using a third-party load balancer, and that load balancer cannot handle the log capacity. It's too much log and it's too much traffic, and it was like having the bottleneck. And then we thought like, okay, we have to do our own homemade load balancer. So Virtumetric did its own load balancer. It's completely integrated with the product, so it's load balancing the data. And then we had to do our own clustering, Raft-based clustering. So we don't need third-party things. Virtumetric just scales and automatically clustering itself. It's a perfect thing. And another one, API gateway. We can migrate the data. We can migrate the client connections easily, automatically. So it was perfect as well. And then we added a built-in queue and cache system in case we are not able to communicate with the API, so we can store the data on the locally. And the next ones, we want to do a built-in database. You might ask, like, why? I mean, you are using the ClickHouse, but not every customer needs big requirements. So we also want to do a very simple scenario, simple features. So we are going to do a built-in database. This can be maybe embedded database, but we are going to do our own one to handle some specific cases. And another one is making a built-in geo-available service. We want to send the logs to the closest Virtumetric instance. So we would like to do our own geo-available service. And soon we will do this. We will give the service as well. So we don't need a third-party load balancer, etc., to do this. So what's next? We are going to simplify the service architecture. And to do that, we will remove the .NET. We will remove the Kafka, KeyDB, and Zookeeper. Because, yeah, I will give you some reasons why we want to do that. But eventually, we will have only 3 or 2 components, React in the front end, Go, and ClickHouse, or for the small instances, only React and Go. That's it. And why removing Kafka? Kafka is like really good or like known stuff, right? One of the reasons was, please remember that we are doing this on remote location. I mean, customer is actually having the Kafka instances, so it's very hard to manage them. If you're not able to keep them in line in your site, it's very hard. And another thing is it's Java based. So we don't want to deal with Java because it has lots of dependency. We don't want to deal all the configuration, etc. So yeah, we didn't want to use it anymore. And another issue is the ClickHouse Kafka engine problems. Right now we are using the Kafka engine on ClickHouse, and it's hard to monitor. I mean, you have to bring the data through the Kafka, and the issues are stored on the ClickHouse or like in the log. So yeah, it's too much hassle, and we would like to eliminate that. Another thing is hard to monitor, hard to manage Zookeeper. I mean, in different customer environments, you are getting many different scenarios and issues. So yeah, it was good to remove them. And Kafka is not designed for large messages. So yeah, it's not good. I mean, we cannot send a log less than 1 megabyte. We need minimum 5 to 10 megabytes because yeah, we are aggregating lots of data. And plus, they don't have a good Golang client. We also contributed some of the open source drivers to make it better, but eventually we thought, yeah, we couldn't do with them. So today, where are we? Today, we do a bunch of monitoring from the different stuff. I'm not going to explain everything, but you see the items. Our trigger, I mean, the main triggering part handles lots of the different scenarios. We can get the net flow at the same time, vCloud. We can do active-active. We even support TFTP, which means we can get the network configs from your devices. So yeah, pretty good. And we support almost every operating system, including the AIX, IBM Power, Solaris, etc. And we have listeners because we are competing with Elastic, right? I mean, we have to get bunch of logs. And to do that, we support many different endpoints to get these data. And then our collectors supports many features like TCP, file monitoring, auditing, etc. So these are all happening in 20, 30 megabytes of memory. And then I'm not going to mention everything, but we have a bunch of capabilities. And we are all able to do this thanks to ClickHouse, because if you are not able to store this data, I mean, what is the reason of collecting them? And today are positioning ourselves as like a middle in the market. Like we do a bunch of things. So yeah, you can imagine us like in the middle, doing everything and showing you really broad metrics. I also want to show you our design, like what we did over the years. It was like different stages, and today we have really nice clarity design. And these are some of the companies they trusted us over the years. I didn't mention during the presentation the names, but yeah, you can see some of the logos here. And yes, this is the our evolution. I hope you enjoyed it. I don't know if you have any questions, but maybe I can check the chat. I will, yeah.
Yusuf, thank you for an amazing talk. I just want everybody to know who is hearing this that we did not pay Yusuf for the praise of Altinity.
No, we were very
that was
appreciated. Yeah,
that was completely spontaneous. Yeah, so for people who are listening, if you're out on YouTube, feel free to throw questions into the Q&A box. We're watching that, or you can put them into the chat, or whatever's convenient. We can also unmute people if you want to ask questions. I do have one. So you said you had pretty amazing compression. What was did you guys do anything special? I know we were sort of working together to get things properly configured, but you got it sounds like your compression rate was like over 95%. And what did you do to get that?
We just listened to Denny from Altinity. He said what kind of compression we should use for each data type. So we listen very well. Yeah, I think we're a good listener. I don't know what is the compression level for the other customers, but yeah. That's not only one customer, by the way. This is the average from 3-4 big customers. They're all with the 99-98% compression.
Yeah, well, particularly if you have metrics which tend to be slowly varying numbers or monotonically increasing numbers, you can get some astounding compression rates on them because they have a lot of patterns to them. But that's definitely that's definitely pretty impressive.
Thanks.
Any other questions from people in the crowd? Please don't be shy.
While people thinking the question, I will show you 30 seconds showcase, like for the people that they can see. Here is a PowerShell, like how we do the monitoring on Windows, for example. It's same with the Linux as well. But yes, here is my PowerShell. Here is my 1 second. I will go to my Twitter. You can follow me or check this on Twitter by twitter.com/Osturk. You can go to some of the tweets here that we have a beta version available for Linux and Windows for now, but macOS version is coming as well soon. So I just copy and put this here, just one single line of code, right? I just click yes. It's around like 24 megabytes of binary, I can say. And you will see how simple it is. So it's done. It started. It's now initializing the dashboard. It's basically scanning the device right now. So it's everything, like the users, the applications, services, everything. And we are doing this less than 30 seconds usually. And yes, it's done. It's doing more process, and it automatically opened the dashboard. So this is the free version, Robert. Of course, our other version has many features, but this will be a free version, so everybody can use it. Today we don't have metrics, but soon it will have also real-time metrics. But this is a pretty real-time dashboard. You will see that like my processor, memories, volumes, how fast it is, like disk drives, network adapters, graphic adapters, chipsets, processes. It's all in real time. I can see them.
Cool. We
Yeah,
got a question
service.
for you.
Yes.
Coming off one of our YouTube listeners. Can you do you have the table DDL available? Because this person who's asking was curious to see the codecs and compression you're using.
It's not available for right now, but Salman, if you're listening, could you send me through the our Discord channel so I can share maybe just one of the maybe the syslog or custom log for the file logs.
Yeah, so I think it'd be cool to just see
Okay.
the compression and codecs. Great. Let's see. Yeah, so here's one. Yeah, I had 5 terabytes in MySQL, squeezed that down to about 100 gigs out of the box, time series metrics. MySQL index is really killer. You can get great performance, but it costs you greatly. So for the person who was commenting, this was, sort of, and I assume the indexes were there to help with performance because you have to index the heck out of these data sets to get the queries to work. Oh, cool. Okay, so there's your table.
So with support of Altinity, we picked a schema like this. So
Yeah.
we transform the data into the different columns. So we are not holding the data in JSON format. We didn't want to do like the after, how can I say, like the data transformation. So we are transforming the data while we are collecting the data. So that was pretty good for us. And so every data is parsed and put it to the each column. For example, for the integers, we use these columns, and for the strings, we are using these. And then our solution in the front end is showing the friendly names. For example, string 1, maybe for the net flow is called maybe source IP address. So we are putting like the different things to the each storage here. And then these are the codecs. I think that's what you're asking.
Yep. Well, that's forcing ZSDD trans. What's interesting is you're on string, the string 1 through n and int 1 through n. You're just using LZ4 with no codec. That's so, and you're getting this level of compression.
Yeah.
That's pretty impressive.
And these are the other parts.
Yeah.
Pretty simple, but I don't know. I mean, I thought everybody's getting these compressions, but yeah, it works really good.
We usually see about, I know my own stuff, if I don't do anything special, I see 80 to 90%. You usually have to, for many data sets, you have to play with it a little bit. So, but that's great compression. Let's see. Yep. Okay, great. So I hope that answers the YouTube question. Any other questions that people would like to queue up? Okay, well, Yusuf, I assume you'll still be around. People can also post it in the chat.
Yes.
Let's go ahead and switch over to Lorenzo's talk. Thank you for an absolutely awesome talk.
Thanks.
Yusuf, that was really excellent. And I would have said that even if you hadn't said praised Altinity. It was really fun. So Lorenzo, you're on. So Lorenzo, as I said, is going to talk about a new serverless a way to make ClickHouse work as a serverless service. So take it away, Lorenzo.
Yeah, can you guys hear me all right?
Yeah, it's actually even kind of loud. Let me just turn my audio down.
All right. Oh, sorry about that. Must be the Italian must see me. And do you also see my screen?
Yes, perfectly. Go for it.
Fantastic. So actually, the topic is a little broader than that, and perhaps kind of monotonic tonight. So it turns out everybody that loves ClickHouse in Amsterdam is working somehow on making logging better for everyone. Which is also part of what's going to be my presentation tonight. So first of all, I'm for those of you that don't know me, I'm Lorenzo Mangani. I'm together with Alexander Dubovnikov running QuickSip, which is a company in Amsterdam. We are ClickHouse freaks. Our company is research and development, and we've been loving ClickHouse ever since. Alexander has a long story that he could tell you about how we migrated from just about any decent database out there through the various options and history to find the best solution, but eventually we landed into ClickHouse. Our core business is real-time communications monitoring. So for the last decade or so, we've been creating and commercializing open source mostly solutions, protocols, projects, etc., all centered about this field. And we have many customers worldwide, from little tiny startups that just use our open source to mega large corporations. Even your mom would recognize they use either one of our products, some of our technologies, and so on. So we're lucky. We nailed something that had a market, and this allowed us to create an open source company that's sustainable. So we don't need investors. We don't need a lot of cash. It's just our customers are basically paying for our development and our evolution. As part of this evolution, we ran into a problem. So for, as I said, the last decade, we helped customers, mostly either telecom operators or companies with a lot of offices, store shops, and whatever that have a heavy telecom footprint, solve their problems. So capturing packets, making sense of them, telephony calls, call quality, etc. But all of them on the side were also, of course, generating other types of data. Call them logs, call them events, call them detailed records, whatever it was. But they were all generating other streams, and they were each using a different solution: one Elastic, one custom, one something else, etc., etc. So rolling back a year ago, I was here on this meetup introducing our solution for that problem, which was porting the Loki and LogQL API on top of ClickHouse. At that point, we were done with this. We were, super happy, and we had this idea of creating a lightweight framework that was protocol agnostic, something that we could, on top of ClickHouse, continuously evolve and refresh. So we went with this, let's say, non-structured logging, or let's say generic data strings first, and use the ideas in LogQL on top of ClickHouse powers to re-implement the same pipeline. So not indexing anything, just running ClickHouse, lots of power, and then we could, finally create satellites around this baseline. And we did. So that idea actually worked out great, and we found a little community, users, and a bunch of partners that helped us make it better. Over time, we expanded. We went from logs to metrics, from metrics to telemetry, into tracing, and we kept adding things, and it was just working out, mostly thanks to ClickHouse. And we got some pretty impressive results. So we decided to make this into our one of our new cores. So all of these things that we were creating put together could create something new and a new solution. So we scaffolded it out. So we made our developers dedicated into this. We put somebody at the head of this idea to put it together. We found partners, and we just bootstrapped something new. And after a lot of work and failures and attempts and successes and so on and so forth, we finally came up with Quarian. Quarian is a polyglot, I call it, observability stack. It does logs, metrics, telemetry, and whatever is coming next on top of ClickHouse. On top of this, we finally managed to latch a lot of ideas that I'm going to try to browse through during the presentation. But before, what is it all about? I mean, logs, metric, traces. It's basically three variants, or three appendices to the same problem. It's tracing something. Either it's a log, a string, whatever, or some structured metrics, or some tracing from inside an application, or, as I said, whatever is coming next, because these things evolve fast. This is what it's all about. And this data could be literally anything. So I'm not sticking to a specific platform logs. I'm just talking about everything, anything, whatever is coming. This is already possible to be done, but you need different tools, different storage platforms, different databases. So it's not something new, but it's kind of hard. And there are a few good examples of solving this problem, but they're quite complex of their own. But the main problem was dealing with all of these formats and not having like a flexible way of just moving them around, which is exactly where we centered ourselves. And this is what our stack framework, I don't know what to call it, really looks like today. If you will, it's a drop-in replacement for Grafana Cloud without any of the Grafana parts except for the UI. So carefully pieced together, API by API, call by call, format by format. This thing replicates a bunch of input, ingress, let's call them, and query formats at once. So it can ingest logs in every format that's popular out there, and more to come. It's easy to extend. We have a full, actually, Prometheus write endpoint and PromQL support. We support Tempo, which is basically a variant of Zipkin, which also works out as open telemetry. So it's a bunch of things on top of ClickHouse. It's everything that we dreamed of at once, and it's usable right away. So all of these formats come together, under one roof. That's not complicated. This is the principle and the philosophy. So it's one, in case of the open source JavaScript version, or two processes. They're stateless, they're scalable, and they speak all of these formats at once. This is designed in a way that I'm going to try to show you is flexible and can scale into the future. So not something that is going to die, as things change over time. Reuniting all of these formats on top of ClickHouse is what makes it cool and powerful. So we didn't invent anything. We're sitting on the shoulders of giants, as for many, building solutions on ClickHouse, because ClickHouse is so good that you can literally build on top of it and transpire its power to users in hundreds of ways, depending on what the vision is. So with Quarian, the users get all the power, full control over the data, because it's in ClickHouse. So yes, we have APIs and formats on top of it, but it's still the same data. You can still go in, break the barrier and just work with it. And the beauty is that they can do it, and this is something that I think Yusuf also mentioned in the earlier presentation. They can do it without changing the way things already work. So this is a platform that does not come with an agent. It doesn't come with its own format. It doesn't have anything. It's just polyglot. So it speaks all of the standards, whether they're real standards or not, de facto standards of observability by itself. So this means that you can just take Vector, Telegraph, Logstash, Grafana Agent, Promtail, FluentBeat, Logstash, whatever is out there that speaks and supports one of these platforms, and just use it in parallel. So it's a solution that's easy to try and compare to something else, because it takes the same inputs. So the pipelines are basically transparent. You don't have to trust another piece of software. And we know that our customers are especially delicate about this. The collecting platform or product can change, but the agents that actually have to install, inside of their beloved applications or hosts, those can hurt if they go wrong. So typically what's already there can be recycled. And at the same time, query languages that are already popular can be recycled. So this is a platform where you don't have to learn anything that you don't already know or know how to use. So if you already know how to use Loki and LockQL, it's identical. If you use Prometheus PromQL, it's identical. If you do open telemetry, well, it's a bunch of forms, but it's identical, no less. As part of this vision, of course, we also have integration with the Alert Manager APIs. So the platform can participate the alerting strategy, even directly from the Grafana UI or an alert manager in general, so that you can query it to get alerting data and just be functional. Is it fast? Of course, because it's based on ClickHouse. Surely not because of our talent. So the way that we designed this is stateless, as I was saying. So you can have as many instances of these running at the same time. They don't need to know about each other. They're all connected to the same ClickHouse cluster, if it's heavy traffic, and they all take care of their own input. So you can load balance in front of them. You can auto scale the application and do all of these things that people love to do. And underneath is ClickHouse. So we just take advantage of its features, functions, and everything that's smart. So inside, Quarian is actually a transpiler more than anything else. It can transpile inserts from various formats into powerful bulk ClickHouse inserts. It can create tables for those formats that are optimized and can change over time and be optimized by the end users and the integrators. And at the same time, it does the same with queries. So when you make a LogQL query, it's transpiled into a ClickHouse query. Same for the Prometheus part, and so on and so forth. This, again, is the malleable part. So as ClickHouse changes, and just today, Alexei announced a bunch of new features, the morning after, we start adopting them, and the user doesn't have to change anything. The agents stay the same, the language stays the same, and the product just continuously improves. So taking a step back, a bucket of formats and agents can now be ingested into ClickHouse without doing anything at all. This is the glorification of being lazy in DevOps. So you can recycle one of these instruments. So from the top down, in this case, we're going vertical. Any industry standard, whether we already have it or we add it next week, it's open source, through any standard agent. So you can collect your data with something that you already use and trust, and then broken down into the formats that we group into 3 major buckets. So something that's like a log. These can be ingested using Elastic formats, JSON. It can be Loki logs. It could be influx DB logs, or something that you write yourself, function. Or it could be metrics. In this case, it's either Prometheus format metrics or InfluxDB inserts. And with some work, you can also ingest graphite and so on and so forth. Or it's trace as per zipping, open telemetry, something like that. So data generated from within an application. Those 3 categories get handled. They each have their optimizations and routes into querying, depending what protocol they have. The majority of them are double layered, so they can be either plain JSON, so you can write simple clients, or protobuf for when you write optimized clients and you're sending in a lot of traffic. It performs magic. So some of our tests show that you can easily do millions of inserts per second with a few cores. This is shared between ClickHouse and Quarian. The proportion is either double or 1 to 3. So ClickHouse still is doing the majority of the work, and we remain like a thin layer on top of it, smart and not a overhead. So it goes really, really fast. If we invert the cycle from ClickHouse, we serve back through the supported API, and we can translate into the languages that clients already speak. So you don't need a custom client, UI, or anything else. This thing speaks things that are well supported. In our case, we target Grafana the most. So Grafana 8 and 9 are basically drop-in compatible with everything we support. Why? Because of course, we're emulating the way they're doing it and the way their client speaks. So native data sources, we just go in Grafana, Loki, Prometheus, Tempo, Flux. They all go into querying, same part, sometimes different paths, but small configurations depending if you deploy them all at once or not. And you don't have to install any plugin ever. They just work. So you just open what's already in a default installation of Grafana, even Grafana Cloud. So from Grafana Cloud, you can connect to a querying deployment, and Grafana doesn't know. So it doesn't know any better. We just transparently act like the backends that it expects from Loki, from Prometheus, and so on and so forth. And we serve the data that it expects. So you can display everything, including complex stuff like the service graphs. So displaying a map of your services or your traffic or the relation between whatever it is that you're capturing. Again, those could be logs, traces, or Prometheus metrics either. And then create links between them. So here's, I see some metrics in my chart that look wrong. I want to see the request rate. And it just takes me there in 1 click, which is, at the end, what we want. We want to make it easy for people to just, get the job done in seconds instead of hours. It just feels snappy. So the performance, we're not going for, this is 100 times faster than something else. There's great products out there. But compared to, the Grafana product itself, everything is snappy. You can select labels, filters, and just use it as if it was, the original thing. But there's nothing from Grafana here. So it's only the UI, and everything else is replicated. So we can do this for metrics. We can just, browse them, and all of these APIs, it's a bunch of them. It's dozens of APIs re-implemented, but in a smart way and in a modular way, so that they can be recycled for many purposes, as I'm going to show you later on. And this is for tracing. Tracing is interesting. This is maybe the most adventurous one. So instrumenting applications to emit data that's related to the metrics that we're capturing from the system and the logs that we're collecting, so that we create one picture where we can jump from one item to the other and really understand what's going on from the outside into of the network, into our application layers, down into the core of the processes if we want to. Well, what if you don't use Grafana? Not everybody loves it. No problem. because Quarian comes with Vue, which is our reimplementation of the Explore experience. And this is a super lightweight application that our team writes. It's made in React. It's simple, fast. It can be embedded. So this is something that you can also, snap into another application in the dashboard or whatever else. And it allows you to browse logs, labels. You can project and extract logs to time series, which is one of the coolest feature, I think, in LogQL that we do on ClickHouse. So taking, a log, filtering them, and then doing time series math on top of them, calculating rates or extracting fields, grouping, and so on and so forth dynamically without ever touching the original data. We can, of course, do Prometheus queries. This is straight off all of the PromQL API. So let's say the data selection and some parts are relayed to ClickHouse, but then on the way back, all of the functions are the real thing. And then Flux, which is also a piece of our puzzle, the latest one. And I'm going to tell you a few more things about it in a second. Flux is from is at the core of InfluxDB 2.0 and their next platform, IOX. It's incredible. It's a language. It's an engine. It's a scripting pipeline. It's everything, and we support it as part of our strategy just to make it, easier. All of these things can also be, collected together. So as a concept of, let's say, some type of dashboard. So it's really powerful. And this thing doesn't require installation. It's a fully client-side application. So it just runs in the browser, connects to the backend, and that's it. So it doesn't, take what Grafana takes. So you can run it anywhere. Curious fact is that our stack is actually developed twice. So there's two versions of the same, almost, really. The Node.js version that you'd find on the main Quarian GitHub repository, and the Go and a little bit of Rust version that powers the cloud and integrations that we have with our customers, basically what's paying the bills. They have slight differences. They offer the same experience, of course. One is faster. You can imagine which one. But the Node.js one is not slow. The beauty of it, again, is that this is a thin layer on top of ClickHouse. So you can run 20 of these things single-threaded in even in functions. I mean, they can be broken down into nothing. And the handlers can be used as workers. So the code, of course, is just JavaScript. So it's easy to take, let's say, the log handler and just turn it into a function and deploy it on Cloudflare. And boom, you have a CDN that inserts data, collects it at the edge. You don't care how, and then it sends it to you in a reliable way using the Cloudflare high-speed network, and so on and so forth. And it's easy to prototype with. So this is where we usually try the dangerous things and try to implement something first, because it takes minutes instead of days. Once we have good ideas, and or for things that are only belonging to the car, is the Cloud Go Rust version, which is incredibly fast and super solid. So this is the one that clocks. Sooner or later, we're going to release benchmarks for this. But again, this is one designed for cloud integrators, people that want to offer this as a service to hundreds of thousands of users, and they need partitioning and all of these other things on top of ClickHouse, of course. So it's a nice story, but as you know from the previous presentation, this is a busy space. There's a lot of these things, and then of course there's Grafana Mimir, there's Victoria Metrics that we love, there's Influx with IOX, and why do we need another one? So a few reasons that keep this alive in our hearts and make us go ahead is staying agnostic to formats and vendors is important to us and our customers. So this is a two-way polyglot idea. It means that everything that we're doing works with the other products, but it goes two ways. So all of these ingesters, workers, and pieces that we're doing, they also can accelerate the other products just as much. And this is good. The design is stateless, portable, and cost-effective. This is made to save money. It's not made to break work records, if not in savings. And it's on top of a database. This means that unlike other solutions, it's only object storage. It's some custom, super optimized format. Sometimes you can get into that, but this is your database, your favorite database. So you can do whatever you want with this data. We're light. There's no bloat. There's nothing that's not useful for something. And the philosophy is that less is more, because this makes it possible to extend things without carrying too much weight on your back. For a database freak, this is a cool platform because you can actually change how it works from the inside out. Again, ClickHouse comes up with something new, you adopt it inside without ever touching the agents, the ingestion protocols, the pipeline. How you collect data doesn't matter, but you can still apply all of those optimization as you write it and read it. So by changing the queries, you change how the product works and performs. This applies to compression, codecs, just anything you can think of, you can change it. And then you get granular control about what's inside. Lots of reasons, and one is that it's fun. I mean, it's fun and healthy to have and make alternatives because they keep an ecosystem active, they push innovation, and it's open source. So me and my team for sure have a lot of fun. Giving it a try is super easy as well. For the JS version, it just takes Node npm or Docker. You can run in Kubernetes. We have recipes for ECS, GCP, DigitalOcean, Fly. You can run it on a Raspberry Pi. And we have a bunch of articles. And of course, thanks to ClickHouse, everything that works there, you can use. So you want to use block storage S3 as your only storage, you can. It works just fine. And of course, you have to deal with the scaling, but there's tools for that. And it's all made with ClickHouse. So that's the only thing we have. There's no Redis, there's no Postgres, there's no this or that. It's pure ClickHouse. If you want to add complexity on top of it, you can, but you don't have to. And of course, as we work on all of these things, we have to experiment, do research and development. And here we link with what we had in the introduction. So we end up making things that connect to this thing or make it work better or make it future ready. They don't really have anything to do with it. So the first one is about ClickHouse. So ClickHouse, I mean, we don't have to say anything. We all work here. We all know it. Some of you are masters and know it better than me. But it runs on a server. And that's where it is. And sometimes some of our pipelines are just basically processing the same data sets or data sets that don't change that much. And very often they're just sitting somewhere on the cloud. For that, of course, using a ClickHouse server works, but it's quite expensive to have idle instances just for running that type of job. So we wanted to have a cheap serverless function to cover that job. It didn't have to be the fastest, but you have to be the cheapest and cost effective. So equal performance to a normal node, but next to zero cost. So we hacked one together. And of course, we started from ClickHouse Local, as many of you can imagine or already read as I'm talking. ClickHouse Local, you already know it, so I'm not going to go into it, but it can be customized a lot. So it can be built with or without pieces of ClickHouse, so you can strip it down. And with a lot of work that we describe on our blog, I'll give you a link, you can make it into a static application that's small enough and fast enough that you can throw it into a Lambda function or into a small host or even free ones around and just work. So ClickHouse, basically local, plus a super thin launcher and API on top of it, can act like a very simple ClickHouse that you can just run. And this is an example. By the way, we embedded Play with it. So it just looks like you just open a normal ClickHouse server and you can run any query that doesn't involve local tables. So there's zero local storage, but you have all of the other drivers and functions. So this is a classic Altinity example from the blog, running in the smallest free instance that we could find and pulling this data from S3, really simple, 20 lines in 0.9 seconds. Can go down to 0.7 on the averages we've seen, but this is 0.7 of free. And you can run it anywhere. I have a few running on Glitch and other, of these freebie instances, and it just works great. You can give it a little job, and if you like, you're making a calculation every few seconds, every minute, you can move into those functions, and they just do it for you. They talk to your same storage. They can even talk to your own ClickHouse, and do the magic. If you go on our blog, blog.quarian.dev, there's a full adventure as of how this is made. I think we have it here. Wrapping a serverless ClickHouse part 1 and 2, where we go into how it's made, how we build it, the problems, the sizes, the compression, the libraries, and so on and so forth. Our layer in V that launches it from memory, all the way down to the queries that we run on it. So it's a lot of work. If you're interested into this, you can go and read it. Same thing we did with what I'm afraid is maybe a dead binary. I'm curious if it spawns any discussion later in the Q&A. But Quarian and some of our other tools can also run as UDF binary functions in ClickHouse. Unfortunately, it looks like this feature was not really designed for like real life usage. I don't know how many of you have tried to make something with it. We have, and it works, but unfortunately the way of managing it is, leaves a lot to be desired. So who knows, ClickHouse, please, would you make UDFs better so that we can create awesome stuff with it? Because static functions, are awesome for this. We have some example on our Magical repository, by the way, how to make UDFs with Node.js, with V, with Go, and a few more. We have a ClickHouse Mate in our labs, which is a take on ClickHouse Play. It's light, not as light as Alex says Play, of course, but it's customizable, and this is made for embedding into applications. So we use it in some of our applications. It's made in Angular, and it's done by our team in Ukraine. So it's tragically bomb-proof, and we're super, super proud of our guys there that keep on working on our products, and they're unstoppable. And then there's Flux. We talked about Flux earlier. It's at the core of Influxity, and it's amazing. I mean, if you never use it, please do. Give it a try, read it. It's everything. It's functions, it's programming, it's pipelining. It's amazing. So we did the same thing. We took Flux. We made it standalone. We didn't find any other standalone versions of Flux. It seems to only exist into Influxity. So we took it out and we open sourced, of course, everything. So it's on the Metrical repository on GitHub. And this one is really small and it's really fast. So it's 14 megabytes only. So it's, it loves to run super fast. And we actually forked ClickHouse Play, and we made a version that works with Flux that speaks CSV. And you can see here in the screenshots. It can generate data. It can do anything. If you have a browser, go there, fluxpipe.fly.dev. It's a public demo, and I think you're going to be amazed. And since, like Quarian, we emulate standard APIs, actually, you can use this as a data source from Grafana. So you can add this serverless endpoint that doesn't exist and give it Flux jobs, and then it just runs them and it displays them in a dashboard. It's like nothing short of amazing. Now that we have all of these pieces, where do we put the data? So URL engine, and then I'm almost wrapping it up, is one of our other favorite features in ClickHouse. It's just like so functional. It's not for everything, but a few things and simple things that you can do with it are just super amazing. So we made a service for it. So URL end or URLengine.com is basically a pasty, but for your database tables. So it's a serverless, distributed, and super free URL engine. Like a pasty, it only gets protected with a secret URL. So you get to choose, a secret key as long and complex as you want, and then you can just use it. So you set your custom URL from anywhere, and you just select data from it. So this is super cool. You can use it to exchange dataset states, keys, whatever you want between your setups without having an extra cluster or without them knowing anything about each other. So all of your nodes can write or read something from one of these shared tables for fun and profit. This is a public version, but if you want, the code is public as well. So you can run a private version of the same and have a pasty between your ClickHouses on your cluster. This is, by the way, entirely running on Cloudflare. So it's only made with workers, and it uses data as a free storage, also based on the key. So it's public, but quite secure, all encrypted. And it's fun to use. So if you ever have to paste something between two setups and you don't want to sweat too much or make a real query, you can use this as a vector. Querying is already powering some things on the cloud. So we have services launching, and there's a bunch of things that already actually use it in the background and don't publicize it. And we're super proud of that. There's going to be more coming. And if you like this and this type of stuff, you should check out our blog, blog.querying.dev, where we have a bunch of articles, mostly about ClickHouse, hacking with ClickHouse, or hacking with something that can be hacked with ClickHouse or exchange data with it. And we just have fun in public, trying and failing to do cool things together. So if you will, just take a hop there and let us know what you think. And that's my presentation for today. I hope I didn't go too long.
Not at all. Thank you, Lorenzo. Hey, there's already a question from the crowd here from Ramazan. Can you show us the DDL you're using for the logs? Because we want to. We're curious.
Sure, it's Outnight. Well, let's see if we have Vladimir and Alex from my team. Hopefully they joined the call, the Zoom call. They're the ones making it, and hopefully can bring up some interesting data. Are you guys there by any chance?
Yeah, I'm here.
All right.
I'm here as well.
Let's see. So should we make you guys presenters or allow you guys to present?
No, it's okay. I can just answer any questions if you come.
Well, do you have like, can you show the DDL for some of the, for one or more of the tables? That would be really cool if we could see that.
I can send a link so Lorenzo can open it. So let me send a link.
Cool.
Any other parallel questions?
Hey, are there other, so Lorenzo, sorry I didn't mean to scope down your talk just to be serverless, but that was the thing that stuck in my head because you showed me this a while ago. What other serverless, do you know if there are others? I think there are a couple other serverless implementations of ClickHouse floating around. I mean, obviously, ClickHouse local is close to serverless ClickHouse. In fact, that's what it is. So just curious if you could comment on that, because this is a pretty interesting area.
Well, look, the first thing we did is look at what other people were doing first, of course. And the idea was to do it in a way that could be easy to replicate. So the exercise here, of course, if I have to be honest, we have some more advanced prototypes in the works that go a little deeper into actually just doing it with ClickHouse or using it sort of like a library. But those will come. For now, what I wanted to do is just like demonstrate the layering and how it's done in a clear way, and at the same time just have fun with the idea. So this by no means claims to be like the next best way of doing it, but it's functional. And the other principle was I want it to be free. So many other implementation that I see in the works are more focused on succeeding and being perfect. Ours is not. This is more designed to be fun and free. The other part is that I actually wanted it to be compatible with educational purposes. So whether it's fast or not, this serverless function, if it's running on a free host, it means that we can spin up free labs and people can actually learn ClickHouse without installing it at all and without running on somebody's expense on any infrastructure. So it really makes it free to create like educational experiences for ClickHouse, and that's the scope for now.
Okay, great. Did you get that link for the schema? That would be cool to look
actually, no.
Yeah, I have it, but I
Yeah,
can...
yes, I'm sending in QA. Yeah.
Oh.
Maybe I
You
will
can
answer
or
here.
you guys maybe can share the screen if you want to, but
I
again,
sent already in QA. I answered already in QA.
Awesome. By the way, it's open source, so I mean, many of these answers are actually easily answered on the repository.
Yeah. Can I send it in the chat or somewhere, because I don't have disabled every.
It's disabled for me as well.
Uh-huh. Can you enable?
Can you guys get in? Can you guys not get into the chat?
Uh-huh.
Oh, that's
no.
weird.
It says the host has been disabled attended chat.
Uh-huh.
But I am using web version of.
Here. Oh, just a second. I've got the link. The link is in Q&A. Here, Lorenzo, I'm going to post this into the chat. I hope you can see it.
Okay.
Yeah, that's correct.
Are you able?
Yeah,
Lorenzo, are you able to see that? Oh, do we lose Lorenzo?
But I can see it now as well. So it means that everyone can see it.
Okay. Well, I think Lorenzo, are you still on?
Yeah. Sorry. If I switch tab, it stops working. So yeah.
Okay.
I'm just gonna stay put. Yeah, but I'm here. And again, thank you, Robert, for having us.
Here, what I'm going to do is, if you don't mind, I'm just going to go ahead and share screen on this link, which everybody can see on the chat. So this is the time series. So you're doing. How are you guys doing the time series? Are you just doing one key value pair for each in each row of the table?
Well, do you guys want to answer that, or should I?
So we have two tables, one with a time series stream It called samples v3. It is like a lot of key values, but one metric or one log line.
Mhm.
And we have an index of it, which is called time series and time series gen. It's a bit lower. It is key value index and one fingerprint, so one stream index. So in order to make things go faster, we have one key, one value, and one fingerprint. So it's time series gen. So if you want to search by one or two key value pairs, it goes to this table and filters fingerprint you want to see. And if you want to see just set of tags, we have time series table. It is a bit high, on the top. It is time. It is very first time series.
Oh yeah, right here.
So it's fingerprint and labels JSONified. So there are three tables making logs and metrics working.
That's because mostly we don't search the real logs in this construction, just like Prometheus, we search tags.
Got it. Okay. Do you and what does a query look like then? So you're going to join these tables to I mean, what's your left side table going to be in this? Is it samples v3?
Yeah, we have time series, any order, any left join. When we are going to look for logs or metrics, we have to join, but it is like the system is going to be a bit more smart. So if we do not want to make some complicated things with tags, so not like change tag or like alter the tag value or like on the fly, then we may do two requests. One is for time series, the second is for samples. It works a bit faster than any left join, and sometimes we do sub request filtering only the time series rows we want, and we make left join with subquery. It works a bit faster as well than just inner any join of the whole table at once. These are three main ways of what we do with this left joins.
And what's the volume of data you're storing in this at this time?
Samples,
setups, yeah.
Samples are, well, the biggest I've seen is about 4 billions of samples, and for time series, well, in average, it's about 300, 1,000 rows. So we have a very tiny table of time series and huge samples v3.
Which of course it's based on partitions and etc. So it makes search faster.
Right. So you're partitioning by start of day and then ordering by time within it.
Yeah, and also we would like to also change in time series labels should be not string, it should be JSON type. But it will also speed up a little bit search.
Have you guys tried? Have you guys tried the JSON type, and what's your experience with it?
Yeah, it looks okay. Vlad, go ahead.
My own experience was it's a bit raw because I couldn't make materialized view on it, and there is not a lot of client libraries supporting JSON for now. At least when I tried it, maybe now the things are a bit better, But the time, like about two months ago, it was pretty low featured.
Well, it's exactly since this time it's ClickHouse get this new Go exactly driver. So it's maybe the game will change. Of course, the idea it's very smart. Yeah, so it's make this automatically let's say make parts of sub keys of JSON structure and make own columns. It's good way. And of course, it will speed up the search in many times. But yeah, as Vlad already said, we have to wait for updates of this JSON type for all, let's say, common drivers, especially what we use here, and also in Go Lang, and yeah, and materials view. It's also some. Yeah.
A small aspect here to just to chain into this, otherwise it's maybe misinterpreted. If we ingest JSON, this only applies, let's say, to how we manage the labels for searching them. But the objects, if you ingest JSON into Quarian, it's actually not indexed. So we do this at query time. That's the beauty of it, is that everything sits the way it is, gets compressed the way it is. And then you decide when you query, if it's JSON, if it's log FNT, if it's a custom format, if you want one key out of it, of all of them. So in querying, this equation is reversed. So the problem is quite applicable only to certain areas, whereas we don't want to really have an ingested JSON type.
Yeah, it's you're right. It's only for indexes normally in time series, just to make exactly this search much faster.
Okay, great. Are there other questions from the crowd? We showed the just looking to see if there's anything out there on. Nope, don't see anything on YouTube. This is actually great. I love streaming. Okay, if there are no more questions, I'd like to open it up. First of all, thank you very much, Lorenzo. Another great talk. I also would like to just open it up now to any question on any aspect of ClickHouse. So if anybody has a ClickHouse problem that you're interested in talking about, feel free to chime in. I can, as before, I can unmute people. Here, I'm going to stop my share so that it's so that we can see people. If anybody wants to, talk about stuff that they're working on with ClickHouse and are curious about, the floor is yours.
Well, I have one small question about the things I'm working. Well, I used to work on it a short time before. So let's see. We have replacing merge tree table, and I made it replacing because I sent there like megabytes per second, like maybe 10 megabytes, maybe 20 megabytes per second. It's like thousands of rows. But I want it to be cutting index, let's say. So this table will always not more than 15 kilobytes. So it will replace like thousands of times per second. Is it a good way, or is there a better way in ClickHouse to do this? So to just compress the data, to cut out almost all data, like hundreds of times per second.
But sorry, Vlad, to interrupt you. Are you talking about optimizing of partitions? Yeah. So collapse.
No. I don't want to optimize nothing. I just want the replacing merge tree to do its job, to optimize it whenever ClickHouse wants it. I know that it will be done, but the thing is, I will really load the server with these things. So rows will be duplicated thousands of times per second.
So what that means is if you had, and what's your key for the rows? I mean, what are you using to?
Oh, well,
like
I want to, like the way I'm using it is to just leave thousands of random rows per some conditions. So I want to just do thousands of random specimen. I want to like to work with later.
And the idea is that these are distinct entities, and then they're going to have a bunch of updates on them. Is that what, did I understand that correctly?
Yeah.
So, okay. Replacing merge tree. Actually, I have a picture of it, which might make it easier. We're very interested in replacing merge tree. It's actually one of the cooler tables in ClickHouse. Let me see if I've got give me 1 second here. I might have a picture, which I think would be easier to have a discussion about it. 1 second. I'm going to pull up. I'm actually doing a talk about this on Tuesday. I'm going to do a share here, and we can, let's see. Kante, you were saying something about sync connector. Okay.
Oh no, I just said I have a picture on the repo I can share.
Okay. I've got one right here. Let me go ahead and share this, and if you've got a better one, we can use that. So just so everybody knows how replacing merge tree works, you have we use replacing merge tree because we're using it to replicate data in from MySQL. And so the rows coming in are going to have a primary key, and we use that as we're going to use that as our sort order. Let's see if I've got that correctly here. So we'll have, here's an example. Order by film ID, that turns out to be a primary key. So you're going to have some primary key that identifies these rows. Is that correct?
Yes, it is.
Okay.
Hash value of the value, the percent 1000.
Okay, so yeah, because what will happen is you have thousands of these things coming in. So that's kind of like, and you said thousands per second. I think what's going to happen is this table is going to be very large, and what will happen is when you run a query, so you'll have to do a final on it to, like if you're going to do, so the way that replacing merge tree works for everybody who doesn't know about it is you have a version, you have a key that identifies the row, and that's the thing that you're going to be focused and updated. Then you have this thing called version, which as new rows come in that have new version values, they basically replace the value. And so in order for the at some given time, like after an update, this is going to be the value of the row. So it's been updated. We also use a sign, an underbar sign, because we want to be able to represent deletes. But the point is, you're going to have a zillion of these things, like this middle row right here. You're going to have just a bunch of them. And the question is, so every time you query, ClickHouse is actually going to have to go ahead and merge those rows. So depending on how often are you querying this data? Because the one thing I see is your queries could actually become quite slow because they would have to filter through a bunch of unmerged rows to get the final value.
So you think it will merge too slowly, to not oftenly?
It won't merge. Yeah, what will happen is it will merge eventually, but it might be after minutes or longer, depending on, because ClickHouse can tolerate pretty big partitions. Like they can run to billions of rows. Oh, Alexander, you're going to say something.
Yeah, I want to exactly, because
go for it.
I opened the issue probably, if I remember, it's 1 year ago by ClickHouse, exactly to make it with, let's say, replacing merge tree implementation a little bit better. And at least 2 days ago, Alexey Miloidov closed this ticket as resolved. So now replace merge tree supported special params, what I advised, which you can force to make compaction after some timeouts. For example, you have replace merge tree table has partitions, yeah, which let's say our interval, yeah, and you can define make compaction after let's say 3600 seconds. Yeah? And ClickHouse will do it automatically in background. So this partition will be automatically collapsed and removed all duplications. This is how it will work, because final.
Do you have that
Sorry?
issue? Do you have that? If you can post the URL for that issue, because that'd be interesting to look at.
Yeah, absolutely. I can do it right now. But
Yeah, that'd be
final,
wonderful.
unfortunately, this is exactly the killer of performance. Yeah.
Yeah.
So Verify is. I also exactly discussed with Alexei, and what it's better to use with it's 2 tickets normally. First tickets, it's about partitions optimization. This is exactly after some period. It's idea I copied from Cassandra. Yeah, I want to say. So we did exactly same for time series. And second one, if you make a huge query which goes through multiple partitions, and once a partition has been compacted and doesn't require any final request, ClickHouse will be skipped final, and it will be fast. So normally final will be only on the last partitions. Yeah. What require this compaction. This is exactly I'm very thankful to Alexei what his team implemented with 2 requests, because it's a game changer for this replace merge tree. And let me exactly send it with tickets.
And one thing to be clear about then in your implementation is you have the so you are partitioning by time, but what that could mean, right, is that you will actually have you'll have rows for the same key that are potentially in different partitions. So there'll still have to be some sort of merge in the query. How does that work? Or maybe your data set is something different from.
I just cut out by date. So I'm partitioning by date, and I cut out by the time the user asks. So I will not look at the former days, like the past days, if users looks at today.
I sent exactly one issue, and let me find another one.
Oh yeah, managed to if people can see the Q&A.
Yeah, you can forward if you can.
Yeah,
I could not find another one, but it's also related to engine. They also implemented engine URL, which normally before it was if you have a material view on a table with engine URL and HTTP server where you try to send data, it's disconnected. All chain has been exactly broken. Yeah, it will be drops all table in all tables. So also they implemented this request. I can also send it. Let me see exactly here. And another one, let me find, because.
Yeah, here I'm just copying this stuff over into the chat so everybody can see it.
Yeah, it's very nice what they fix it, because really it's this feature we waited for a long time.
Oh, thanks Raihan. We've got people on YouTube are looking for this. Let me send the ticket links over there. So just a second, YouTube people, don't worry, help is coming. So I think a lot of people are interested in replacing merge tree right now. It's a pretty useful table. So I'm just sending the ticket links from Alexander.
Another one I will try to find, because I have millions of emails. Sorry, guys.
Yeah. So I think what that comes down to, the issue we're sort of circling around is that in the replacing merge tree, let me get the picture back. This is if you have a lot of additional versions and they're unmerged, you're going to have to put final on the table name, and you then have to resolve them, and that has to be done at query time, and it's slow, particularly if your partitions are big. So and I think that I know that one thing that Alexander, maybe we'll ping you, because one thing I'm planning to do is write a blog article on replacing merge tree that covers the structure as well as some of the performance considerations that you're bringing up.
Yeah, of course. Yeah.
Yeah, this is great. Vladimir, did that help? It's
Yeah, it's an interesting opinion. I
Yeah.
will check it. Thank you. Thanks a lot.
Also here, it's a question about update. If it makes real sense to use update or just keep the full object in memory and just update it everything, yeah? Because by performance perspective, it will be same.
Yeah, actually, this is what you're looking at right here is a representation of MySQL binlog before and after images.
Okay.
And that's why we use the sign. So there is, actually, there's another PR that we're working on right now that may interest you, which is to put final into to have final be a table property, so it will automatically be applied. Oh, here's a question. Wait, final doesn't cause compaction, right? As in the data doesn't change as a result of final. Absolutely right. It does not cause compaction. What it's doing is, since the data is unmerged, it merges it at query time before it's fed into aggregation.
Yep.
So because ClickHouse, in fact, it's not all that different from the process that you go through to handle aggregates. Aggregates will get merged, to ensure that you get the correct result. So cool. Any more questions? That was a great one.
Oh, by the way, one more small question to this. Have you tried that new RocksDB table? So it's going to update the primary ID on insert, right? It's RocksDB's key value pairs. So have you tried the performance of this new stuff?
I have not tried it. Has anybody else on the call tried it? Sounds like crickets. So you know what you could do is try it and write a blog article about it.
Yep, I will write about that.
Cool. Okay, great. And there was actually there's interesting. So there's somebody on the YouTube channel says I've been using having plus aggregates instead of final, much faster depending on the query. Yeah, so there's different ways to get these effects. One more trick, actually a totally cool trick on replacing merge tree. So the way that we do it, if we want to represent deletes, we use this sign column, and this doesn't exist yet in replacing merge tree, but some of the guys from Content Square are have a PR open right now that will add a sign column, and it will basically make replacing merge tree have the same semantics as collapsing merge tree with a sign column. And we're getting somebody I think is I was getting a duplicate voice there for a second. So anyway, and then what they will also do is the deleted rows, they'll make them disappear automatically before they get fed into aggregation. So right now, if you want to we use this scheme, but there's no built-in support for sign. What we in fact use is row policies. So let me see if I have an example. Row policies are actually really great ClickHouse feature. That this is a row policy for that table that prevents anything with it. If you get done with, if you do your final and then you have a -1 row, the row policy prevents it from being shown. So it doesn't go into aggregation. So basically this is with modulo some performance issues, this is a really great way to handle updates and deletes. Okay.
I want to say, Robert, sorry, it's Alex here.
Yeah.
I want to say it's exactly because this is exactly implementation of copied from Cassandra as well. Because
Yes.
It's Tombstone implementation, because exactly how it's these roles in Cassandra works.
Yeah.
They set to Tombstone, and query will be just exactly skip this row.
Yeah,
that's to be honest.
Yeah, and I actually think that like there's also lightweight. There's also a lightweight delete implementation that's
Yeah,
going
it's
on
exactly
inside.
it's same copy
Yeah.
from Cassandra.
Yeah, but the thing
And
about
then
the lightweight delete though is it still requires mutations, and I mean, our experience has been they're pretty slow. So, yeah, okay, and we're getting, actually, this is a really good point. There's somebody out here. UN Owen was hollow. So I have trouble wrapping let me just say what he said. I have trouble wrapping my head around collapsing merge tree. You need to know the key and that a previous row exists properly to delete it. It feels like it's fragile because of adding the signs. Yeah, that's exactly the problem with collapsing merge tree. So the cool thing about replacing merge tree is all you need for version is a monotonically increasing value, which is easy to generate from a lot of data sources. You can even use timestamps for it if you want. If you don't have row updates more than once a second. So what we're doing is basically putting the sign part is good, but the fact that you have to know the old version number to collapse things properly is bad. In fact, it's really bad. And so that's why there's this work going on to make replacing merge tree actually, with the monotonically increasing versions plus the sign column work. I think this is actually as you're saying, Alexander, this is kind of like what Cassandra does, and I think is a really good long-term implementation, particularly if we can fix some of the performance problems.
Yeah, I think it's more problems because even with collapsing, even with optimization, it's take time, and sometimes it's based on our experience with our one customer. This compaction doesn't work well in Cassandra,
Yeah.
unfortunately. Yeah, it's we have some ghost roles, and we have to exactly implement some pages on our backend, which exactly skips these ghost records.
Yeah, and we're trying to, and I think if there's just like a little teeny bit of work there's another problem with replacing merge tree that Alexander, you guys may have seen, which is you can't put final on a join table. That syntax isn't supported. So again, that's why we want this property to be stuck on the table, because then your right side tables can also have final. It'll just get applied automatically.
Yeah, and also don't forget about distributions. Yeah, distribution table. It's also brings some issues.
Good. Hey, are there other questions? This is really, I'm glad you guys are interested in this, because this is something that's super topical for us. My colleague Kanti is here. Oh, here's more. Okay, for people who are listening on YouTube. Hey, you know what we could do? I've got an idea. For the next meetup, I'm going to do a talk on replacing merge tree, and because this table is so interesting, and I think it's kind of underused in ClickHouse, partly because it originally had some big performance problems, but those are getting solved. So Alexander, if you want to show up for that one, we can have kind of a free-for-all to talk about your experience.
Oh, it will be great, of course.
Yeah.
Thank you so much.
Great. Let me just put this links in, and we got another question here. All right. I'll take this one first. I don't know how many people are wondering about this. Is the recent video about ClickHouse Keeper the go-to, or should I stick with Zookeeper for now? Right now, we're seeing it at Altinity. We do not recommend. Here it is. If you're using a new, if you're building a new system, ClickHouse Keeper is probably a good solution. One of the big things about it is that you can use it during development. You don't have to install Zookeeper. You can make all your tables replicated, so it's really good. But it is not a good replacement for Zookeeper at this time. If you have a working system with Zookeeper, our recommendation is don't change. And let me get you guys the KB link. I'm gonna just let's see. All right, here I'm gonna post this link. Actually, here's if people don't know, there's now a couple of we have this knowledge base where our support guys just throw stuff in. So Yeah, so there are performance issues on loaded systems, and then there's some usability or operational issues. It's still not quite there. So that is, so that's why we don't recommend that people switch. That's just for us. You can make your own decision. I mean, I'm not trying to tell you what to do with your life. If you have a new system, as I say, it's good. Let me just post this link, and I'm going to post this in YouTube and also in the chat. So is there anybody else here that's been using ClickHouse Keeper and wants to comment on it? Let's see.
Okay, just if I can, we use in one setup, and I can say it's much better than Zookeeper. So even based on your comments, it's you are not recommended, but it works much better than Zookeeper, and it's stable.
Yeah, what was it you liked about it compared to Zookeeper?
Okay, it's Zookeeper is it's based on Java. I don't want to start war, but it was a couple of let's say problems with connectivity. It's lost connections, lost partitions, meta files, etc. And we discussed also with ClickHouse guys, and they said, we develop with ClickHouse Keeper, and yeah, we installed, and so far its latest version, I don't remember exactly, 22.3, I think, and so far it's very good.
Good. Okay. I think over time it will take over. Mostly because you don't have to do anything extra. Moreover, as a developer, you can run it inside ClickHouse.
Yeah, you can run it inside or outside. Yeah, so this is exactly the beauty of that.
Yeah. Yeah,
and
that's a really great feature.
Yeah, again, it's not about Java, but unfortunately, it's take a lot of memory. Unfortunately, some, let's say, glitches, issues, it's still present. Yeah. And so far, we are happy.
Good. Okay. Great. So that's a vote for. I think the jury is there's still different votes on this. Yeah, as I say, an existing system, if it's stable and it works, I wouldn't change. But if you got a new one, this is probably the way to go.
It's worth to try.
Yeah. Any other questions? These have been some really good ones today. Oh, let's see. Question in QA not answered. Why is group by faster than final? In my experience, I see that group by primary key plus argmax. Yeah, so, all right, so here's the question. It is, hey, Raihan, was this one further up? Did I just miss this? This was in YouTube or in the Q&A?
It was in QA.
Oh, thank you. Thank you so much. Yeah, Ryan's my colleague and he's helped. Okay, so why is group by faster than final? My experience, I see that group by plus by primary key plus argmax column version is 3x faster compared to final.
Yeah, maybe I can clarify.
Yeah.
So I ran final on a table that basically had no duplicates. I know that there may be less than 0.1% of duplicate. Then I see that I don't like the performance. I tried group by on the primary key, and for columns outside of group by, I just take using argmax, take the latest version value, and it runs maybe 3 times faster compared to final. And I'm just curious why.
Yeah, so this is a really good question because final, it's kind of hard to understand what final is doing, and the question that I always have about final is it seems like it has to do 2 passes to process it correctly, because you're talking about replacing merge tree, is that correct?
Exactly.
Or are you talking? That's correct.
Exactly. Yes.
Yeah. So in order to be sure, because the point of final is it's going to do a merge so that the rows that go into aggregation are only the rows that would would have appeared if things had been fully merged. So my guess on this is that how ClickHouse does this, and if somebody knows the code, they can tell. I need to look this up for this talk I'm going to do, but my guess is they do one pass to do merge, and then you do a second pass to to actually process the aggregates. So I think you end up with two passes. And what happens in the meantime, like this is where I think this gets kind of slow. I don't know how it manages the data that comes out of final, because it's really something where you have to do a full final in order to be sure that you've got the right rows. I don't see how ClickHouse can do this in a parallel in a pipeline fashion. So I think the answer might be that you're doing two passes. Does anybody know if there's a better answer on that? Okay, I'll tell you what, this has been bugging me for months, because the final behavior is real, like we all know that final is slow. The question is, what is it doing down there? Which would explain exactly why it's slow. More to the point, if you knew exactly what it was doing, it would explain how to make it fast. Like, when is it going to be fast? We know, like from what Alexander said, that if you can skip partitions, of course it's going to be fast because you're managing less data or
Sorry,
skipping less data. Yeah,
Robert, is about this
Yeah.
final, because
Yeah.
if I can be wrong, so I need to check code deeply, but final take all records in your interval which you ask and make virtual compaction, so it's compacting memory all records, and after apply filter which you provided in where, or pre-where doesn't work
Exactly.
even worse.
Yeah.
And therefore it's very, very slow, because you have to go through all records, make this collapse all records, and after apply again. So it's normally exactly like you said, it's two scans, which it uses. If it depends of course how many records you insert with this partition or in this range.
Yeah, two scans. So what you're saying is two scans. Moreover, you can't do a push down of the filter. So it's like
and therefore, exactly in this case, we did some tricks. Exists some params. I don't remember exactly. I need to check in our implementation. You can skip. First of all, you can use max value by this ID. In your, can you open your slide?
Oh, sure.
Replace.
This one right. This one right here.
Yeah. So normally you can make a version if you're looking for a special ID. You can immediately take the highest version here.
Yeah, just take the highest version. That's a single scan.
It's single scan, and it's after you can make aggregation on your side, if you need it.
Yep.
It's the only way, which helps you, or do exactly by grouping by version and skip, take only first one.
Yeah.
And this will be much faster than to use final on full partition.
Yeah. So I think that what you have just heard from Alexander is the precise answer, that aggregation is a single scan. Moreover, you can group by, like in this case, I could group by the ID if I was selecting a bunch of them. And in this case, it's just going to be blindingly fast because it's a single scan. And ClickHouse is really well optimized for this.
Yeah, we did it exactly implementation for our customers, and it was around 25 times faster. It's based on, of course, how many records you have in this partition, but we have daily partitions.
Yep. Good. There's another question here, which is that came up from Ramazan. Thank you, Raihan. We already have version collapsing merge tree, which has sign and version columns. What is the purpose of having a sign column for replacing merge tree? The problem is that a collapsing merge tree is just hard to use. And if I was just going to pull it up, collapsing, and I'll show you why. Because we looked at this, Kanti, who's on the call, we looked at this pretty closely, but basically, hopefully they have a good example here. Yeah, so, all right. Here's the way that collapsing merge tree works. So you put a row in, so you define it, you have a sign column, and it doesn't always have to be called sign, you can actually rename it, but here's the first row. It comes in, it's got to have this, I believe it's using duration as the, does it, do we see an example here? Presumably duration is the, is your version effectively. And this thing, user ID, is the thing that you're collapsing around. That is the entity you're tracking. So what happens here is when you want to do an update, you want to do a change, you basically have to give it the old row with the original version key, and then you add a new row. The problem here is generating this value, that 146. How do you know what the old value was? This is just really hard to do, because that row, one of the problems, it might be really expensive. You might, in the worst case, have to go find this row and see what you say user ID, what was the last thing that was changed. In fact, MySQL materialized, materialized MySQL, which is the engine that will read off a bin log, in fact keeps a hash table, I believe, to remember these things. They have some sort of implementation like that. So this is just, for a lot of cases, it's just unusable. And the problem is you can't generate this previous version. So that's why the difference with replacing merge tree is the versions are just monotonically increasing numbers like this. And what it will do is it will take the last one. This is actually a little bit tricky because I think there's a race condition here, but anyway, if that makes it clear, that's why we don't use collapsing merge tree. Replacing is just simpler. Cool. Hey, we're at 2 hours. Any other hot questions? All right. Well, thank you, everybody. This is a really awesome meetup, and thanks for 2 great talks from Lorenzo and Yusuf. Really appreciated them. And Alexander, thanks for all the knowledge on replacing merge tree and all the great questions. We'll be back we'll be back in December. There will definitely be a talk on replacing merge tree. I think this is something we're going to dig into deeply and really explain how it works so you can use it in your apps. And if you have a talk, let me know. We'd be delighted to have you. So,
okay.
With that,
thank you so much,
everybody. Yeah, thank you, Alexander. Talk to you soon.
Thank you,
bye,
Robert.
Everybody. Yeah, bye, Lorenzo.
bye bye.
Bye.
Bye-bye.
Bye.
Bye-bye.
Bye.
Yeah, bye.